Welcome everyone to our joint webinar with myPV and together with our compatibility partner from Bluesky. So today we will be presenting a joint system, how our system can be compatible with the Greenrock battery with their salt batteries. So in the webinar, we first move with the introduction, what are our introduction, and likewise then we will move to Greenrock for the introduction, and we have their managing director in our webinar. He will be presenting our webinar. So starting from introduction from myPV. So the guy on the top is entrepreneur for myPV. So he is a founding member of myPV with his experience from PV inverter industry as well as from solar thermal system. He is able to manage our product growth. And on the second is myself, Talal. So I will be presenter for this webinar, and with my background, I have a background as a testing commissioning engineer and extensive experience in the case of battery systems with the testing, and for a part of year I have been handling the international sales at myPV. And the bottom is the Reinhardt, so he's our managing the product management with his experience in a research field. So our company started in 2011 as a distributor company, and later we changed our business model to pure manufacturing company. So now we are manufacturing accessories which are working with the PV inverters for producing the hot water as well as electrical space heating. So moving next, I will be throwing ball to Thomas, and yes, Thomas, you can provide with short introduction and we can continue with this interesting webinar.
Okay. Thanks for your introduction. Thanks for the opportunity having that mutual webinar. This is Thomas Kraus from Bluesky Energy. We are an Austrian-based company. I'm managing director of Bluesky Energy, and we focus more on energy storage, on photovoltaic added electrical energy storage, and I would like to browse through a little bit about the main topics with respect to storing excess photovoltaic energy in big batteries. That's what we all do about that. We are an Austrian company. We are based in Upper Austria, founded since 2013. We've got the focus on smart and sustainable storage technologies, and we have got now, and that's brand new, local manufacturing for our beloved saltwater batteries. And I think now back to you, Talal.
Thank you. So thanks for your introduction. So moving with the portfolio from myPV, and then afterwards with the product portfolio from your side. So as a background, what important is to put your energy, you have an options to store that energy in the battery, as well as you can store the same PV energy in hot water as well as in the space mass for the floor. So in a typical European size battery, it's a 5 kilowatt. So with the 5 kilowatt battery, you can of course you can store the energy in the battery system as well. And likewise, our systems, as mentioned, are compatible with the battery systems. And here today it's Greenrock. So if our battery system is compatible with them, we are storing energy. First, in the case of battery has a priority, and then likewise we can store that energy into thermal storage. So in case of thermal storage, you have more bigger capacities that can be seen in a typical tank, which is found typically in the household is about 300 liters. So you can store up to 15 kilowatt hour energy in a typical tank And likewise, what type of facilities can adopt our product? So it's clear that hot water demand can be met in old buildings as well as new buildings. So no ambiguity into that. So here is a pie chart where you can see that the energy demands for a typical household with a 4-person household in the old buildings as well as new buildings. So the amount of hot water is roughly the same. As you can see in the chart, it's 4,000 kilowatts, so that is the same amount. But the difference is in the older buildings where the space heating energy demand is quite higher because they lack the modern technologies. They need a more amount of energy to maintain the space heating. But coming to new buildings which have adopted passive solutions, they are having modern solution, and due to that they have low energy demand. So that low energy demand can be met with also myPV product. And myPV is the best solution for hot water as well as space heating in the new buildings, and for the old buildings we recommend only for the hot water. Then a typical system, what a typical system looks like. In a typical system, water heating and space heating is carried out by using grid power. But what myPV offers is that during the daytime you can heat up the water as well as do the space heating by using renewable energy, in this case solar energy. So in the daytime you are heating up the water using the power from the sun, and during the nighttime power from the grid can be taken. So from factory presetting, it's deactivated. It's called a boost backup. So from factory presetting, it's deactivated, but with the access to the settings, this can be activated from the settings. Then the question about the self-consumption. So in the market where the battery systems have adopted the market, those are well famous into the market. So there are a number of ways to increase your self-consumption. So in a typically European household, as mentioned, that there are 5 kilowatts, so your self-consumption is roughly at 30%. So you can increase that you can increase your self-consumption by using one of the myPV solutions. So it can be increased up to as high as roughly 80%. But nevertheless, if a person combines both the systems with the battery system as well as water heating system, the person can achieve as much as his own PV self-consumption, up to as high as 90%. So then on the right side, there's a day chart curve. So the day chart curve shows how much power shows a typical usage in the day chart, where the energy is first stored into the battery storage, and when you have surplus power, when the battery charge is full and power has no other way, then power is diverted towards hot storage. Then here I will start with our AC product portfolio. So we have mainly two products in our portfolio. One is the AC and second is the Aceto. So I will start with the ACLYE. So here is a look how our systems look like. So in a home where you have a PV system, you are producing your AC power with the inverter, and then that power is used at home, as well as in this case it's a Greenrock battery, so the battery is storing that power, so it prioritizes the battery charging, and then likewise the load at the home, so those are prioritized. And when there's surplus power that's going to the grid, that power is detected by the PV inverter's meter, and when that power is detected, that power is diverted towards thermal storage. So what the unit itself looks like, it is a single phase 3 kilowatt. So the working principle is based on linear power stage control. What it means is that the load at the house are constantly changing. I need to go one slide back. So the load at house is constantly changing, and likewise the PV production is also constantly changing. So in order to have a right amount of energy, we are working efficiently with our system that detects that surplus power exactly. So it varies constantly. At some second it's 300 watt, and another second it goes up to 1 kilowatt. So that power is constantly changing, and only that surplus power is used for thermal storage. What other points are that we are not using thyristors, so we are using we are not using thyristors or triacs. We are using the PWM signals. Our load is working as a pure sinusoidal current consumption. Other points are that we have a system which interacts with the web interference. So there's a cloud system available with the ACLYE. The user can have a web interference setting with the ACLYE. Likewise, different devices can be connected with it. Up to 11 devices can be connected with it with the master-slave configuration. And as mentioned, that the boost backup can be also turned on from the web interference. Then we have a Aceto. So the working principle for the Aceto as well as ACLYE is the same, but the difference is that the ACLYE has already an immersion heater connected to it. But for the users who already have immersion heater in the tank, or users are looking for a space heating solution where they want to connect infrared panels or electrical space heating mats, so then Aceto is the solution where any existing solution can be connected with the Aceto. Further about the Aceto mentioning is that it is a more sophisticated solution compared to the ACLYE. How the answer lies into its first in the picture, that it has a color touch display screen, so it offers more flexible options. And in terms of its technicality, on the left side it has the output, so it's a 3 kilowatt output single phase, and then on the right side it has the RJ45 connection, which is the standard connection available both on the ACLYE as well as on the Aceto. Then the temperature sensors, those can be connected on this orange plug, and likewise on the right side it has a relay contact. Depending upon the operating mode, that can be used according to that. Other unique sales point is that the Aceto itself is of very small size. It is the size of roughly A5 paper, so it can be only handled in one hand. And if an installer or the person is installing the cable, installing at the site, he don't need to open up the terminal box. All the cables are just need to plug, because as you can see in the bottom picture, everything comes with the plugged in form. In terms of technical details, yes, the more of the things I have mentioned, but you will have the slides after the webinar, so you can go through it. Likewise, it has the web interference facility also, and there's a multiple device can be connected together. Then moving towards the big brother, so Aceto 9S is the big brother for the Aceto, which I showed you earlier. So the picture is the same because the size and everything is same, only difference is on the bottom side. So here what you have is a 9 kilowatt input, and then you have 9 kilowatt 3-phase input, and then likewise you have 3 output, which each 3 kilowatt. So it's a 9 kilowatt unit, which is for the 3-phase system, and the users can connect, as mentioned, any resistive load to Aceto. So you can connect the infrared panels, you can connect any electrical filament, any resistive load. Only important is that its rating should be respected. So each output is about 3 kilowatt, and in terms of its unique point, which the competitor product don't have it also, is that you can order the output. So you can also order the AC output, for example, at 1 to 3, or likewise at 3 to 1. So you can change that setting also depending upon what you are looking on your project. So depending upon project, that's completely flexible to adopt. Then some of the technical details of Aceto 9S. So the important is that it should have a neutral connection to it. So line to line 400 volt is a must for Aceto 9S. Without neutral, it's no go. And then then for the users which are looking for immersion heaters, users that are looking as a security, that they want to have completely myPV solution, we can also provide immersion heaters ranging from single phase 3 kilowatt as well as 9 kilowatt. So those can be also provided on the request. Yes, coming on to the advantages. So as mentioned, that up to 11 devices, same like ECLYE, can be connected together, and as mentioned, it has a touch screen. So in terms of its communication protocol, so it's quite flexible. We have a number of compatible partners depending on PV inverters and battery systems and smart homes. So how the user wants to adopt, it depends upon him. And yes, the important principle of working is the same for ACLYE. The working principle for Aceto is the same as ACLYE, that I mentioned, that it works in a linear power stage control, as only the surplus power that's available, only that power is sent into the thermal storage. One of the example in the Aceto 9S is that many users think that it's working as a 9 kilowatt constantly. But what happens is that as the surplus power remains under 3 kilowatt, only first output is turned on. As soon as more surplus power is available, the output 2 is turned on, and as soon as more than 6 kilowatt is available, the output 3 is turned on with the availability of more surplus power. Then we have a power coach tool, so it's highly recommended for the sales team as well as technical teams. It's available on our website. There is no special login required. It can be also accessed by end customers also. What the point of its recommendation is that you can put different parameters, how how much is your PV systems depending upon your location, because the solar irradiation changes according to the location. Then likewise, how much is the electricity tariff, how much is the tank size, and how much people are in the home. So according to that, you put those parameters, and then you can get a rough estimation of your PV self-consumption, as much as you can see how much savings you can do yearly. It gives also a rough estimation of my PV bill, my PV devices bill, which how many devices you would need in your system. And then coming to what's integration with Greenrock, so how our system can be integrated with Greenrock batteries. You can find the operation manual also on our website. So with the search keyword Greenrock, you can find this manual, as well as you will find the link on the YouTube about it, how this, because this webinar will be recorded, so this will be also available on the YouTube channel. So here's the copy of EMS hot water, so energy management system. What the user wants in the first step, yes, he or she needs to look into the schematics of how the communication cable should work out. So after that, the step comes about the compatibility. So the user needs to adopt a Modbus TCP on the web interference setting. So this web interference, as mentioned, is available on the AC-LYE as well as Aceto single phase and 3-phase Aceto. So the settings look same. Only thing that has to be checked is with the Modbus TCP, and that activates the compatibility with the Greenrock. And then the next step is Thomas will explain how that should be activated in the energy management system of the Greenrock. So I will now pass it to Thomas, and we'll be back at the end of the webinar.
Okay, thank you much, Jalal. So the question is, why should you use a battery storage at all? It's all about, optimizing self-consumption. It's about matching the energy demand and supply. When you've got that excess energy which generated by the sun in the afternoon and nobody's at home, it's better you can use it then when you are at home at night, so to match demand and supply. And of course, one important functionality, that's the emergency backup functionality. That's when the grid fails, when the blackout comes, then that storage can switch within 20 milliseconds. And you build up your own grid and have got your own power supply independent of the grid. And of course, that is also available that you are black start able, meaning that you can really completely be an island and off-grid system independent in respect of energy without any grid over time. So that is why batteries are used in that case. And what we see here on the left-hand side is a normal curve. What we are seeing from a household in Europe, we can see on the blue line here, you've got the night. In the morning, you get up, you've got a shower, you get a coffee, all have got breakfast, the washing and the washing machine and the dishwasher are running, nobody is at home, children back from school, at night we are cooking. That's the normal case of a normal consumption day, average-wise in Europe. And the good or bad thing then is when we've got the sun, the yellow is really the PV-generated energy. And unfortunately, it's not matching out perfectly. And so therefore, the battery storage is now the guy pushing that energy, which we are generating in the course of the afternoon, to push it onto the areas where the energy is needed, into the afternoon, evening area to watch telly with your energy, or in the morning to make your espresso with your own sun-grown energy from your photovoltaic. That's why batteries are for. On the other hand side, You can use the smart stuff like myPV, hot water instruments to get the best out of your photovoltaic energy, to take that energy, basically what's needed down there when you take the shower in the morning. You know, it doesn't really take into account to really heat up your boiler in the afternoon the day before and then use the hot water. And those are the functionalities where a clever energy management system, which is built into our storage units, can make sense, makes a difference for you, and shifts the demand, which is outside the range when you are producing the energy, into that area to match it properly up. And that is, for example, done with the myPV heating elements integrated into our storage units. But of course, we can also use Wi-Fi sockets, that the washing machine is running at a time when there is excess PV energy and not at a time when everybody's leaving home. Or we can use e-charging in days like these, being future-proof, you know, charging your own car during the course of the day when you've got excess energy to have done a drive at night with the powered car. Of course, we can integrate also heat pumps. And those are the elements which, besides the storage, can really optimize your excess PV energy. That's where the whole thing, I explained that already. We can integrate with multiple consumers, so heat pumps, e-charging, Wi-Fi sockets, hot water with myPV. We can, of course, do also the peak shaving functionality. When we see we've got a certain spark in energy every day, and we want to ensure we are cutting that spark off, then, of course, it's also possible that we are switching that on and make basically a cut on shave that off in order that we are shifting the load properly. And one very clever functionality is also the dynamic load management. Yeah, that we are ensuring when there are bigger consumers around in a house or commercial buildings, that we are balancing them out, ensuring that we are not accessing the point where we are getting the energy from the grid. And I always get overly excited when I'm talking about those EMS functionalities. And of course, that is available on the app. It's available on the laptop. You can see that. And what we also, of course, see is that people are getting more and more aware of their behavior, how they consume the energy. How much kilowatt hours is consumed when you are at home or not at home, on a weekend, on a course of the day, makes you more sensible and also likable, joyful. How much does your photovoltaic really bring? All those type of things available, ready, plug and play, easy to understand. And of course, we all love to drink beer, but we also love our battery management system. And basically, in that analogy, our battery management system is that clever waitress which is capable of really pouring that beer properly into your glass, that you have got a proper glass of beer. And our glass is our battery, and the battery management system is that beautiful waitress enabling to do so accordingly. And it's a good match. We've got the battery management system, electronic software in one piece, and accordingly our battery fully synchronized to ensure we are using those batteries at its finest. And so the question, what we are getting asked very often. So I've got a photovoltaic on my roof, but I've got no clue, not the faintest of an idea, how big should that storage be? And there is a rule of thumb. Luckily, it's a 1-to-1 match or a 1-to-1.5 match. Whatever is your kilowatt power, kVp, on your roof, that should be the same size in kilowatt hours. For storage, or 1.5 in terms of kilowatt hours. So your storage should be the same or a little bit higher than your PV capability. Of course, all dependent on consumption and seasonal fluctuations. A couple of terminologies in order to confuse you all off. There is a capacity out there, which is kVh. That's basically how much is fitting into that battery. And there's a load in kVA, how much you can pour out of that battery. You've got a C rate. That's the ratio capacity to load. So basically, how much can you drain in relation to that capacity. kVp, that's basically what the photovoltaic can bring at its maximum. There's a round-trip efficiency, what's poured into your battery and what you can drain out of your battery. There is, unfortunately, something which is left off, and the round-trip efficiency gives you how much of that energy is coming back again. And of course, there is energy density. It's basically the stored energy per volume. There are very tiny things out there like lithium-ion batteries, and there are heavy, big containers like flow batteries. So it's always depending on how much energy you can store on that sizing. And another couple of words in terms of battery technology. In all honesty, there is no wonder battery out there, and we have got that not either. But there are a couple of features out there. For example, lithium-ion batteries. It's a very predominant technology all in our toys, in the electric cars. We've got the lead battery, the good old lead battery, which we've got as car battery. We've got the salt and salt water batteries. That's us. We from Austria have got a salt water battery here in the middle. It's all natural, all good. And then, of course, there are flow batteries around there and multiple other innovations. And as it seems, the next wonder battery is coming around the corner every second week. And there is a little comparison. We clearly say there is no wonder battery out there. There is lead acid, there is lithium, there is the Greenrock salt water battery, the most sustainable and safe battery in its like. That's the strong points of that. But again, there are also weaknesses. It's energy density, it's power. And therefore, you need to have an addition if you want to have the best of both worlds. And that's our product portfolio. We have got the green, the sustainable one, the very safe one. That's the Greenrock salt water battery. We've got the Vigos. That's the outdoor beast. That's the rough guy for tough environments. And we've got the Cell 3050. That's our performance racing horse, providing a lot of power in a very short time. So you can choose. It's all yours. Couple of words to the AQ sodium-ion battery. That's basically that main technology what we are providing and what we're also producing over in Austria. It's the AQ sodium-ion battery. The R&D is around since the 1970s. And the main advantage is it's intrinsically safe, not having an opportunity to get burned or exploded. And there are no scarce materials in there and no toxic materials in there at all. And what we did, basically, we took that wonderful technology and made it even cleverer. So basically what we introducing a battery cell balancing. We have got a dedicated charging profile. That's basically the beautiful waitress ensuring we are pouring the energy in properly. We've got a dedicated electrode manufacturing process. Of course, it's patented, made in Austria. And we have got also a cell pressure management, which is dedicated to the technology and coming from our R&D team. So that's the thing, how it looks like. On the left-hand side, you can see it's something of a battery. That is a 2.5 kilowatt-hour battery. It's about a meter in height. And what's in there, it's all natural, non-toxic. It's an electrolyte, which is based on sodium-ion water. We've got a synthetic divider. We've got the manganese oxide cathode. We've got a carbon titanium phosphate anodes, and we've got a current collector. That is a really one that is enabling to get that energy into that battery and get it out again. So how does it work? Very easy peasy. We've got the photovoltaic energy. We've got excess energy. We want to charge that battery right now. And now those ions are traveling to the anodes and going intercalation into the anode, and then the battery is charged. And we want to pull out that energy of that battery. We are reversing the process. The ions are traveling back to the cathode. We are discharging the battery. We are getting that energy out of that battery and use it for our consumption. And there is now a question. And the plastic, what about that? Recycle green plastic? That is a very, very good question indeed, and maybe a little bit disappointing. It's a normal PP, polypropylene, what we are using right now. We were considering using recycled green plastic. The only topic here is that we did not get the warranty from the producer of the PP, because that is a product, of course, which should sustain about 15, 20 years, and they couldn't guarantee that and said, okay, on the first shot, we want to have a product which is that reliable. And of course, we are still considering and looking into options, having also recyclable green plastic used in that battery. So if you have an option and you think they could fit and which can also provide that warranty and lifetime information, then we would happy to hear about that. So an honest question to that. I wish it would be a little bit more greener here. What are the low temperature properties? Lowest operating temperature, another very good question. Thanks for addressing that. Of course, it's salt water. At some point it's getting frozen, and normally we are operating down to temperatures of about 5 degrees centigrade. That's where we feel comfortable with. Transport is a little bit lower, but it shouldn't get much lower than that. It's an indoor battery, and of course we need to be wary of our salt water in there not getting frozen and destroying our electrode structures. So that is how we are then working and installing that battery in the field. We've got those green batteries at the bottom, and we've got our electronics plug and play in there. There is all the smartness of the EMS and BMS, everything in there. And we have got a Greenrock Home with 5 to 30 kilowatt hours and a Greenrock Business with 30 to 270 kilowatt hours, which we are providing into the market. Yep, that's the Vigos Outdoor Beastcell 3050 indoor sports car for high power and small rooms. That is the good thing now, coming back to a temperature thing, salt water stops at around freezing point. That technology can go down to minus 30 degrees centigrade. So that is certainly something for rough environments. And it's got a cycle expectancy of 20,000 cycles. Okay, so carbo cap. It's the 9th most abundant element on the Earth, which we are using. There are no gaseous decombustions, and that's the best rated environmental capability lithium-ion battery. So it's within the bunch of lithium-ion batteries, the most sustainable one. And that's the product, Vigos Outdoor Beast Indoor Performance Sports Car. And that's how we do that. For example, that's a private home in Germany where we put our beloved saltwater battery under the staircase. Then we've got a truck garage in Germany where we put that over there. That's the beauty with saltwater. You don't have got that risk of flammability or explosion. You could put it literally everywhere. So we put it somewhere in the garage. Vigos, so of course, it's an off-grid application in the Alps, a very beautiful scenery, completely no grid, farms, milk, everything, sun, wood, forest, and our Vigos powering it up all. And that's a retirement residence in Germany where we power up with the Cell 3050, the whole bungalow. That's an apartment house in Austria. What we are doing with the green batteries and sustaining it there. And of course, we have been deploying multiple projects around the world and are happy to do so. Very much so, to optimize that excess energy for more energy autarky and for a mutual path into a greener nature. Okie dokie, that's from me, and I'm happy to get to you back, Talal. Thanks.
Yeah, thanks, Thomas. That was quite interesting how our product works, how the salt batteries work and how we can prioritize our energy with different types of options. So PV, the idea is to utilize maximum of the PV energy, and it should be first, as mentioned, prioritized at home and likewise in the battery storage and then into thermal storage. So what some of the details that you can find our literature, such as the data sheets, marketing material, etc., can be found over our download center. You don't need a specific login to it. Those can be found in different languages: English, German, French, Polish, Dutch. So many languages are being covered, and records of the webinars are also available on the YouTube channel. And yes, as of mentioning the YouTube channel, so there are these records that can be found. So different installation as well as commissioning videos can be found. Those can be really helpful for the installers. So most of the videos are in German, but there's a translation available in the subtitles. Yeah, so our product can be found on our distributor list. So there's a distributor list on our website, so the user can go and just look up for his local country. Or other is that when our systems are directly available for purchase for the installers as well, so mostly those our sales are covered with wholesalers, but for installers that's also direct purchase is possible. Then then I would like to end this webinar today, and likewise I would be looking forward for some of these interesting questions from your side. So here's one question, Jordan.
Yeah, so one question in respect to the discharge and charge currents that are possible for a 10 kilowatt hour system, storage system, not in ideal temperature. You know, grid peaks costs more in the future, so a system has to perform and power all devices at the same time like people want. And I cannot agree more. And therefore, we have got our power horse, the Cell 3050, which is capable of providing for 10 kilowatt hours a peak load of 12 kilowatts. That's a really power horse. It's a C rate above 1, and it can do so down to 30 degrees centigrade. So I think if that is the application you want to have power also in cold temperatures, that's the way to do.
Okay, so yeah, that's I guess if any other question you can put in the chat box, so we have enough time for Q&A, and we would like to have some more questions to it. So I guess okay, then I would say thanks, Thomas, for today's webinar. So
it was a pleasure. Thank you very much.
It was interesting to having you, and wishing a nice, healthy, because it's important these days. So wishing them some health and have a good evening.
Thanks again, Talal. Thanks, Reinhard, for the opportunity. Have a good day. Ciao, bye-bye.